Hello, friends. Hope you are all well and taking good care of yourself. Today, I'm going to talk about Pearson correlation coefficient. In my last video, I have introduced the concept of Pearson correlation coefficient. It was basically a presentation from Wikipedia, and we have seen the formula of the correlation coefficient and what does it measure. Also, I have given an exercise to you to compute the correlation coefficient of three pairs of numbers, which are minus 1 1 0 0 and 1 1. I have seen that some of you have computed it and correctly got it to be 0. And then I have asked, actually one of the students have asked me that what does this value 0 represent. So today I'm going to talk about some of the properties of the correlation coefficient. It is somewhat tricky and challenging to talk about the proofs in a presentation like this, so I will not make an attempt because one cannot just dictate the proofs in a presentation like this. So rather I will talk about the interpretation of the values of the correlation coefficient and some of the interesting properties probably I'd like you to check on yourself. So let us get started. First, correlation coefficient equal to 0. What does it indicate? If you recall the formula of the correlation coefficient, then it is a ratio. The numerator is the covariance and the denominator is the product of the two standard deviations. One is the standard deviation of the x values and the other is the standard deviation of the y values. Now standard deviations are positive numbers, but the covariance could be both positive and negative, and it could be 0 as well. So correlation coefficient equal to 0 if and only if covariance equal to 0. But what does it really represent? So I had told you that correlation coefficient is a measure of linear relationship between two variables. That is, this number represents the extent to which a straight line can be fitted to the points if we plot the points on a xy plane. But correlation coefficient equal to 0 does not mean that there is no relation between the two variables. But it what only it suggests is that that a straight line is not a good fit to those set of numbers. For instance, the exercise that I mentioned in the very beginning, minus 1 1 0 0 1 1, there you can easily verify that the covariance is 0 and so the correlation coefficient is 0. But if you plot them on an xy plane, you can easily see that the points lie on a curve, and that is y equal to x square, or you could also think that these are points on the curve y equal to mod of x. So you see that there is a perfect relationship between between the two variables here, y equal to mod x or y equal to x square. Still the correlation coefficient comes out to be 0. So it is very important to remember and note that correlation coefficient equal to 0 does not mean independence, or it does not or it does not imply absence of relation between two variables. One can still affect the other, but there may be some non-linear relationship. Only it shows that even if there is some relation, the relation is not linear. So correlation, that is the importance and interpretation of correlation coefficient equal to 0. The other two extreme beings plus 1 and minus 1. So if it is a plus 1, and then it represents that there is a perfect linear relation. That means yi, you can find a pair of numbers a and b such that each yi can be written as yi is equal to a plus b xi, and moreover that b is positive. So we can say the all the points x1 y1 x2 y2 xn yn in this case are on a straight line with a positive slope. In fact, I leave it as an exercise for you to verify this, that to suppose yi is equal to a plus b xi, where your b is a positive number. So then compute the correlation between y1 x1 y1 x2 y2 and xn yn. you can easily see that in this case, what will be y bar? Y bar will be equal to a plus bx bar. So yi minus y bar will be equal to your b times xi minus x bar. So think about the covariance. Covariance is the average of, or the sum of, xi minus x bar into yi minus y bar. So when yi is equal to a plus bxi, so this covariance term will be equal to b times summation of xi minus x bar square, or you can also think of 1 by n summation of xi minus x bar square. And same in the denominator, what will happen? Sy will be equal to b times sx. So you can see what is happening in the numerator. You will also get sx square. In the denominator also you will get sx square, and the bb will get cancelled. So therefore, you can easily see that when the points are on a straight line with a positive slope, then the correlation coefficient is equal to 1. Similarly, I leave it as an exercise for you to verify that when yi is equal to a plus bxi, when b is a negative number, then correlation coefficient is minus 1. This is also a simple and similar exercise. Then you have to same thing, you have to carefully think what is yi minus y bar. That will be again b into xi minus x bar, but in this case b is negative. So that is the way. So you can see that when the points are perfectly on a straight line, correlation coefficient will be equal to either plus 1 or minus 1 depending upon the slope of the straight line. So that is a very important exercise. Another third, a bit is tricky exercise, that is, there is an inequality in mathematics called Cauchy-Schwarz inequality. So what does that inequality tell you? Suppose I have got n pairs of numbers a1 b1 a2 b2 an bn, then the modulus of the sum, that is modulus of a1 into b1 plus a2 into b2 plus an into bn, that is less than or equal to square root of summation of ai square into summation of bi square. So if you just think with two pairs a1 b1 a2 b2, what does this say? That mode of a1 into b1 plus a2 into b2 is less than equal to square root of a1 square plus a2 square into b1 square plus b2 square. Whole thing is under the square root. So using this inequality, I leave it as an exercise for you to verify that the absolute modulus of the correlation coefficient is less than or equal to 1. So I have verified three things today. That correlation coefficient 1 means the points are on a straight line with a positive slope. Correlation is minus 1 when the points are on a straight line with a negative slope, and that the correlation coefficient will be always between minus 1 to plus 1. It can never exceed its value can never exceed 1, or it cannot be less than minus 1. So these are some important properties of correlation coefficient that you should know. And then on similar lines we can do another exercise, the effect of change of origin and scale on correlation coefficient. That is, we have got n pairs of numbers x1 y1 x2 y2 xn yn. Suppose I number the x values by a constant a is a positive, that is, then it will be ax1 y1 ax2 y2 axn yn. So can you tell me what will be the new correlation coefficient? Or I can multiply the y values by a, so it will be, it can be x1 ay1 x2 ay2, in this way xn ayn. So then what will be the change in the corresponding correlation coefficient? So this will be the change of scale. And I can also ask you this, that suppose n pairs of number has correlation 0.5, then I add 1 to the x values, that is x1 plus 1 x2 plus 1 xn plus 1. So what will be the new correlation of x1 plus 1 y1 x2 plus 1 y2, in this way xn plus 1 yn. So here what I have done, change the origin of the x values. What will be the change in the correlation coefficient? So questions like this. So I hope you will be able to figure out. You will just have to look at what happens to xi minus x bar and yi minus y bar in these cases. So I am leaving you with this hint. So let us hope that you will find out some answers. So I would expect you to find out the effect of change of origin and scale on correlation coefficient. Thank you.